A square steel bar of side 20 millimeter is subjected to an axial pull of 10 kilonewton. Determine the normal stress and shear stress in a plane inclined at 35 degrees to the line of action of force. Also determine the maximum shear stress and the angle at which it will occur. Okay, so this is the question that is asked. Let us find the solution to this. Now, since this is a square, let me just calculate the area. Area of cross section of bar A is equal to B square, right? B is the side of the square. Please don't play. B is the side of the square. So this is equal to 20 square. So that is how much? 400, right? 400 mm square. That is the area of cross section. The load is 10 kilonewton. Let me just write down the given data. This should be written every time so that it's easy. B is equal to 20 mm. P is the normal load. P is equal to 10 kilonewton. Theta is equal to 35 degree, right? That is the thing which is given. Now for calculating the normal stress, this is the equation. For calculating the shear stress, this is the equation. So for that I need to calculate the sigma first. It is a pull tensile stress developed cross section of bar. So that will be sigma. So sigma is equal to load by cross sectional area, P by A. Now what is P? P is 10 kilonewton. So it will be 10 by area is 400 millimeter square, right? But now the unit is different. This is 10 kilonewton and this is millimeter square. So what you get will be kilo newton per millimeter square. So that is a very strange unit. So let us multiply this by 1000. So this will become Newton per millimeter square or megapascal. So let us calculate this. 10,000 by 400. It is 25. 25 MPa. 1 megapascal is 1 Newton per millimeter square. Sorry, I could go there. It should be sigma. Right? Now I have sigma. I can calculate the normal stress. So normal stress on the plane, on the inclined plane. I'll just copy this equation. Sigma n is sigma by 2 minus sigma by 2 cos 2 theta, right? Now let us substitute the value, or sigma minus this. Now sigma is 25 minus sigma is again 25 cos 2 theta. So let me just put a bracket here. 2 into, how much is theta? Theta is 35. So that is cos 70. So this is equal to, let me calculate this. So 25 by 2 is 12.5 minus 12.5 into cos 2 into 35 is 70. 70 cos. So it is 8.225 or 8.23. 8.23 megapascal. Okay, that is the normal stress on this plane. Shear on the inclined plane. I'll take this equation. It is sigma by 2 into sine 2 theta. Excuse me. Sorry about that. Right? It is sigma by 2 sine 2 theta, or sigma is 25 and 2 theta is 70. I'm directly putting the value here. So this is equal to 12.5 into 70 sine. So it is 11.75, right? 11.75 megapascal. Now there is one more extension. Also determine the maximum shear stress and the angle at which it will occur, right? So we have tau max. So tau max. Tau max is when sine 2 theta is equal to 1 or theta is equal to 45 degree, in which case it will become sigma by 2, right? So tau max is equal to sigma by 2. So this is equal to 25 by 2, and that is equal to 12.5 megapascal. The maximum shear stress occur at a plane inclined at 45 degree, right? So this is the solution to this limit. All right. Now let us take one more quick numerical in this. Two rectangular wooden bars, 100 mm by 150 mm, is connected as shown in figure, right? So AB is the connection. It is, now whenever you need a very long member, it is not possible. So this is called as a lap joint. Find the permissible load on the member if the maximum normal and shear stresses are 1 megapascal and 1.75 megapascal, right? So what he has given is sigma n and tau max. these values are given. It's not tau max, it is tau. Sigma n and tau values are given. So using this, we have to find the maximum value of P that can be applied on this method. Let us find this. So solution. Let us first find the given data. Yeah. Now what is given is the dimensions. B is equal to 100 mm. Depth D is equal to 150 mm. Right? Then sigma. I'll just copy it from here. Sigma is equal to 1 megapascal, and tau these are the permissible stresses. Tau is equal to 1.75 MPa. Right? Now using this, you have to calculate the permissible load P on this. Now from the figure, theta is seen. So theta is 60 degree. Okay. Now what you have to do is, see, we have these two equations, sigma n and uh, tau. So using this equation, you find the value of sigma, right? Whichever is the minimum, we have to use that and find the value of P. So we have the normal stress on inclined plane. What is that? Sigma n is equal to this. Or just put it again. Now this sigma n is 1 megapascal, right? So this sigma I have to find, and I know this. So or let me put it like this, into 1 minus cos theta. This is easier. And 2 theta is 2 into 60, right? 2 into 60, or sigma is equal to how much? Now how to calculate this? This 2 will go on the other side, so it will be 2 by 1 minus cos 120. 2 by 1 minus 120 cos. So it is 1.3333. That is the maximum normal stress that can be applied considering the normal stress on the inclined plane. Right? Now we have the shear stress. Shear stress on the inclined plane. What is that? Tau is equal to sigma by 2 into sine 2 theta. Now you have to find sigma using this. So, or just paste it again. What is the value of tau? Permissible tau is 1.75. 1.75 is equal to sigma by 2 into sine 2 theta, that is sine 120. So this is equal to, or sigma is equal to 1.75 into 2 is 3.5 divided by sine 120. 120 sine. It is 1.732. 1.732 megapascal. Now, based on the normal stress, the maximum normal stress that we got is 1.33, and based on shear we got it as 1.732. So we have to use the minimum of these two, that is this value. So using the minimum value of sigma, we get sigma is equal to what? P by A, right? So which is equal to P by B into B. So now let us substitute the values. Or sigma is 1.333 is equal to P by B is how much? 100 by 150. 100 into 150. Or P is equal to 1.333 into 100 into 150. It is 19,995. This will be Newton, right? If you want, you can convert this into kilonewton as 19.995 kilonewton. Say that is 20 kilo, right? So this is how we can find the load that you can apply on this member.